Thank you for visiting the channel Code Breeding. In our previous session, we discussed about linked list, right? In linked list, we have seen the way of traversal, right? Linked list begins its journey, its traversal from the head node, from the first node by looking at the head pointer, and then it checks the current nodes next pointer value to get into the next node, and it continues this particular process till it reaches the end of the node. The identification of the end node is based on the value of the next pointer. If the next pointer is empty or null, it indicates that's the end of the node. Let us see how we can implement linked list using Java program. So you all know about the Java. It's basically object-oriented programming language. So there is class definitions or template specification, and then there will be like object creations based on this class, right? So object is an instance of a class. That's the base or bottom theory. So let us see this diagram and select uh, who will be the best candidate for a class, right? So if you look at this diagram, the linked list itself is a class. Okay, a class has properties and behaviors. So here a linked list has its own behavior, right? The traversal behavior and its own property. When I say property, head can be considered as a property, right? Or an attribute, a member variable, which will always point to your first node. So that's one of the candidate. Now the second candidate will be the node, right? A node can be declared as a class. The only thing is like the relationship should be the relationship should be has a relationship, meaning a linked list has a node, which means it should be an inclusive relationship. So I am going to create an inner class inside linked list. Okay, inner class meaning node inner class. Now what will be the member variables of node class? Obviously it's straightforward, data and next. So what will be the type of data? If you want to store integer, then the type will be integer. If you want to store string, type will be string. Now what will be the type of the next or head? Head and next are the pointers which always refer to a node. So the type will be node. So these are all the important things we should consider before we get into the implementation. Let us go and create a Java program. So I'm going to create a project here. So let us name as the project name DS, meaning data structure. So finish it. I don't want to create any module. That's what I opted for, don't create. Now if you see, the editor created few things for us. SRC meaning it's a specific folder which indicates that's a source folder where you are going to place your class files inside this folder. So there will be a default. So all the class files should be placed in package, right? In Java, package is another important concept. So I did not create any package here because when you create a project, there will be default package assigned. So I'm going to create a class file inside this default package. The class file is, the first class is linked list. Okay, so I'm going to select this option, public static void main. That's the default method, meaning the code execution entry point. The execution starts from here, public static void main. So if I check this checkbox, editor is going to auto generate this method for us. So look at this, editor auto generated this method for us. Okay, now let us look at the diagram. I need to declare head, right? So but head is of type node, so I cannot declare right now because I don't have a node class. Let us create a node class node, and node should be having two member variables, data and next. So let us declare data is of type integer, and next is of type node, because next is pointing to a node. Now I need a constructor, right? Because whenever I create a node, I always create a node with some particular data. So I want to create a constructor here. Constructor should take an argument integer. So I will put my data so that it can be easily differentiated. So this should be saved in member variable, right? So data equal my data. Now whenever I create a node, I always starts with null, right? Next should be null. That should be the default behavior of a node. So I'm going to make it initialize as null. Now the thing is, like, this is an inner class, right, of linked list. Now we need to put a static block here, because why we have to put a static block is whenever a linked list class is getting loaded by the Java class loader, this should also get loaded. This should also get initialized. That's the reason we put a static block. Okay, so let us go to our next step. Next step is, you created a linked list, you created a node. Now let us create our own list, our own custom list, right, or whatever. So I'm going to create my list equal new linked list. Okay, now what we need is, we created a my list. My intention is to store data into my list. Assume our data is 1, 8, 9, right? That's our data, right? Sorry, 1, 9, 8. Let us go with the right example. So I created a list. Now I need a method, or I need a function to add these data into the newly created my list. So I'm going to write a function, public static add item. Okay, so what will be the parameter of add item? It needs a list, right? Because there is a reason for that. I will tell you. A list, and then it needs the input data. So I will tell input data. So I did not put a void here because I'm not going to return anything from this method. So just put a void. Void means this function will not return anything but process few things. Okay, so now let us see. I'm going to add my first data here, right? My list dot add item. So I'm passing the newly created my list and input data. Input data is, let us declare int first data is 1. Then I'm going to pass this first data to here. So eventually we will get this first data, which is 1 here. During the first call, it gets to here, and input data will be 1. Okay, now what will happen? But what will be the first action item? When you try to add an item, you have to create a node, right? How we will create a node? We can initialize node new node equal new of node. So you created a node, and the compiler is complaining, saying, hey, you are going to create a node, but you did not supply the input. I told you we need to supply the input data, right? So I'm going to initialize this node with the input data 1, right? For the first call, it will be like 1. So now a node is created. After the execution of this line, a node will be created with a data 1. And what will be the value of next? Next is actually null. So that's what it's happening here, right? When you execute this line, new node, then it calls the constructor and it gets this input data here, and then nodes instance variable will be assigned a value 1 and next null. So we actually created this particular node. Okay, now what is the next step? The head should point to the first node. How we will make head point to first node? I told you it's a mylist property, right? The head is a mylist property. So I did not declare actually head here. So let us declare head here, node head. So now head is a list property. This head should point to the newly created node, the first node, right? So how we can make it point? We can make it point like list.head is equal new node. When we execute this line, sorry, this mylist, when we execute this line, the relationship is the head is actually pointing to first node. Okay, so this is completed now. Now there is one issue, right? So assume you are going to create second data. Second data. So my list dot add item. You are going to add second data to your list. That's the operation now we are going to perform. All right. So the call will comes here. Second data should be 9. The call will will reach here, and then the value is 9 here. So at that time, we are actually trying to make the head to the newly created node, which is wrong, right? So you created a 9 value here. You created a node with 9. Now you are trying to make head point to this. That should not happen. So you should put a condition saying if mylist.head equal null, then only you should make head point to the newly created node. So this will execute only during the first time when your first node is getting created. At that time, mylist.head will be empty and the head will point to your new node, which is this one. Second time, this condition will not be executed because mylist.head at that time will be not empty because it's pointing to this node. Okay, so now we need to do our else business, right? Else logic, because we created a 9 node here. Now we need to make these nodes next to point to 9. We can simply do one thing. We can assign to we can create a temporary variable node current node equal, let us get the head node. Okay, my list dot head. So this means the current node is now pointing to head. Okay, now I am taking current nodes next should point to newly created node. So I can do this. Current node dot next should point to newly created node, which is 9 now. So I created like this. So now the relationship is established. So that right now the heads next is pointed to here. Now there is one issue here, right? That will be exposed when you try to add the next item. So let us add the next item, third data. Always follow the camel case naming conventions. Third data. Oh, okay. The third data should be 8. Now the execution comes here. So the new node is created with 8. Right? The new node is created with 8. Now it goes into else block. Current node is mylist.head. So the current node will point to here. Now we are trying to make current.node next equal new node, which is we are trying to point this heads next to here 8. That should not happen because that will break the relationship, right? The 9 will be out of picture then at that time. So this is the case. We actually need to traverse from the head, and we should find the last node, right? And then take the next pointer pointing to 8, or make the next pointer pointing to the new node. I hope you got it. So we cannot blindly take the head and assign the next to the newly created node. Then it will break all the relationship. So always traverse to the last node and then take the next, and then point the next to the newly created node. So this assignment should not happen. Okay, here this assignment should happen only at the end of the node. So let us find the end of the node. While current node next not equal null. So I want to iterate through the nodes through the next, right? So this loop, right? This loop, what it does is it comes here next, and then current node equal next. Then when it iterates, then it goes to the next node. Okay, and when it reaches null, or when it sees the value null, then it exits this loop, and then it makes current dot next equal new node. Then it makes this node, this is the current node, it makes that relationship here. Okay, so this is MA3. I hope you got it. This is the traversal happen. Now how we can see whether it's really storing the data into the linked list? So we can actually write a print item method. Okay, public static void print item. Let us how we can print the item. Basically traversal, right? Starting from the head node. So we can copy this piece of code here, because this is a traversal, right? So current node head, then we are iterating it. So let us head node. I am going to print head node data value. So I'm expecting to see 1. Okay, that's my first data, right? Stored in the head. So this should print out 1. And when it begins the traversal, every node will be accessible here, right? Every node 9, 8 will be inside the loop. So let us see node data value during traversal. So it prints that particular data. Now we should call this method using the list object, right? So let us call that method mylist.print item. So I'm passing my list to that. Let us execute this program. You see that it prints 1, 9, and 8. So let me put a space so it will be more clear. Maybe arrow, and then here also arrow. Okay, you see the list has now the head node data value 1 and the remaining 9 and 8, which we will be able to like retrieve during our traversal. So I hope you got the concept. In our next session, we are going to implement a counter to see how many items are there in the linked list, basically to find the count of items in a linked list. Thank you for watching this tutorial.